Hello everyone. Sorry for the long wait whatsoever. So let's just crack on with the revision. So read the question please yourself because it's a lot of reading to do, and I'm just gonna go with the question. You read the question, like pause and blah blah blah. Okay. So this question is all about simultaneous equations. And what this is the revision that I got given to do. However, you can kind of read it, like try to do it yourself, but I'm just gonna do it, I'm just gonna go straight to it because I already done all the sheets, blah blah blah. But I will explain it. I mean, I'll try at least. So, first of all, here's what we have, right? And we have to find what is y and what is x. So, usually in an exam, like basically what you do in an exam, you check what can you do to have one of these the same, like either y or x the same. You can make the y's the same, but that's too much effort. Like you have to times by a minus number and then all blah blah blah. So the right thing to do is to get these the same, and you could have maybe divided this by 2, but then actually no, you couldn't, because this would be an decimal, which is possible, however not ideal. So what we do is we're gonna times this by 2, and not only this, when we solve these type of questions, we have to solve times the whole thing. Like let's say you times this by 2, you times the whole thing by 2, because then it's actually equal. So let's crack on. So over here it actually tells you what to do, because that's the whole point of the sheet. So just multiply it by 2. So this by 2. So this by 2 is minus 4. That's a bit too big. Minus 4 equals, this times by 2 is 16. X, take away this, 24. And basically we're gonna call it 3 from now on. Now we have to subtract the equations. So we have, I'll just write it on the top. We have this, right? And now we also have this as a new equation. So this and this, not this, just, yeah, I'll do this. So we have these two, and we just take them away. And don't get confused on this one thing when you're doing it. Basically, think of it let me show you. So, I mean, how can I show you? Basically, imagine you take away all these separately, not as an equation. So this, so 8yx, take away negative 4y, by the way. So negative and negative gives positive, so this will be 12x. You have to remember the laws of maths, if that makes sense. Yeah. So 12y, then these two negative is a 0, so there's no x, which that's what we want. And then after 9, take away 9, take away this, we get 33, because negative and negative equals positive. After that, we divide this by 24 to get y on its own, and y is equal to 2.75. So after that, we have to substitute y into the second equation. Why the second? Because we transformed it, so might as well just do everything with it. However, we could use this one, but it doesn't really matter that much, So we have 2 y's, so that will be 5.5, negative 5.5 equals y 8x negative 2. And now what we want is we want x is on its own, so we just transform this here. This creates a positive 12 to this, which equals 6.5 equals 8x. Then we divide it by 8. And then what we find out is x is equal to this. It's not the full number, I just, I made it. Basically, yeah, this is the number that we get, and y is 2.75. So this is question done. Now here's the second question. Read it please, and then let's do it together. Okay, let's go. So this time in this equation, basically there's a small error over here. We don't see the formula, like equation, but the equation is basically s equals 7t plus 2t squared, because like that's the logical thing. So yeah, sorry for this small error, but that's not a complaint from me. To me, that's a complaint to my college. I can't remember who gave this to me, but that doesn't matter. So let's just go with the flow. Over here, we're trying to find out what t equals, and for that, in this type of questions, we just have to create it like equal to 0, because in this case, we're able to like move everything around, blah blah blah. So we create like, add the 0. No, we don't add it straight away like this. We take away the 15, so everything actually equals 0, because like you can't have this equal to 0 but at the same time to 15. Do you know what, like, do you have the view? Like, basically, yeah, you should get it. Then we have to rewrite the equation into the form of this. So how they got 10 and 3 is basically, you need numbers that like add up to 7t. So 10 and 3 add, like negative 3 add up to 7, so that works out. The reason it's not like, times 7 to equal this and then plus to equal this is because when we do that, there's usually two numbers involved. However, here we have only one, so we can just make them add. But you'll kind of see where it comes from, because after that we do the then, and basically over here, as you can see, they kind of make us use our own brain. So we have already basically we have to write what's missing to create this over here. So this thing equals to t squared. So after 2t squared we have 10t, so we just put a 5 because this equals 10t. We already have the 3t over here, so what do we need to create? 15 is well, 5, because it's over here. So now we can see that the what we're using is kind of the 5 only. However, after that, then we have to use like as a common factor, which is the 5, because the common factor to give, that's the common one. And how that works is basically these times and by, like, it's all basic maths, but I don't know if I should. Yeah, I'll just do it to prove my point, I guess. So this times by this, and after that it times by this. So 2t squared, then negative 3t. Oh wait, no, I'm doing it wrong. So this times this, then this times by this, then this times by this, and then this times by this. Hopefully I'm making sense in my own brain. Let's just check it. So this one first, 2t squared, and then this, like this, yeah, plus 10t. After that, we do the this, negative 3t, and after that, this one, negative 15, yeah, equals 0. And then after that, each equal each of the brackets to 0 and find the positive 2. Oh, so now you see how we got 2 brackets, right? Pardon me. We are able, like, because in each bracket there's a t, we're able to find there's basically going to be 2 answers for the t, and we have to pick out which one suits the best. So over here we have the 3, literally right here. I'll do this in blue. So 3, because 3. After that, over here we have a 5 here. And then to find t, we have to have t on its own. So we move the 3. So what we have right now is, no, this is what we have right now. To find t for this equation, we need to plus 3, so 2t equals 3, and then divide by 2, so t equals 1.5. Let's just put seconds straight away because we're working out, like, wait, no, is it, yeah, seconds, because we have the distance. Wait, let's just quickly check. Yes. Oh no. Yeah. Here. It's not seconds. Oh yeah, it's distance. Distance is in C for some reason, but yeah, C. Distance. So 1.5 C. Distance. That's just how it is. And after that, we have T, like this one. Let me do red. T plus 5 equals 0. Same thing. T equals minus 5. And over here it kind of explains that the negative value of t is not basically feasible. Literally, feasible is basically basically negative numbers when it comes to distance. I mean, this is distance. Oh wait, I got myself confused. Function of t. Oh, we had the distance. So guys, look, we had the distance. That's why we used 15 here. So we were looking for the time t. Oh guys, I'm so sorry for this mistake. That's my mistake. So the answer is going to be 1.5 because it's not negative. So that will be the answer for this thingy majiggy. Okay, here's the next question, and please read it, and read it carefully because, well, pause the video when you read it. It says opened topped, so this circle here basically doesn't exist. It's open. There's a circle here, like closed circle, and this thing over here, there's nothing. Keep that in mind. The reason that matters is because in the formula, the total surface area of a cylinder, this is a cylinder, is 2 pi radius times like height plus the 2 pi r squared. So all these are times, of course, but like that's the formula itself. And as we know, this itself is the formula for a circle, and a cylinder usually has 2 circles. Since over here there's only 1 circle, we will take away the 2 because we need only 1 circle, the circle here, because we're looking for the surface area. So we know the height, we know the radius. That's everything we need. So what we do, we just substitute in the equation. So what we will do is 2 times pi times 2.3 times 6.4 plus pi times 2.3 squared, and all that equals to 109.1 millimeters squared. Remember, area is in meters squared. So yeah, this was kind of an easy one. So here's the next question. Like, this is the question. Read it, and then yeah. Okay, now let's go. Over here we have to use the logarithms laws. So let's just go straight to it. Like, you can read, basically always try to do it without me, but like, yeah. So let's just go. First of all, let's actually add the logarithms to each one. So right now it just goes like straight away to applying all the forces. However, it doesn't tell us to actually add the logarithms, which is like, that's, you know what, I had to literally ask ChatGPT about to this question. So ln, like the normal log, 12 plus ln in brackets e take away 10, and then that equals to ln2. So we added all the logarithms because in that case we'll be able to use actually the logarithms. You can't use the logarithm laws if there's like no logarithms. Yes, there is a logarithm here, but like, yeah, you have to have them everywhere basically. So we're looking for like the time, right? Time is here. So first of all, we have to move it all around and use the laws. So first law that we're going to use is the plus law, and it's given here. So we moved, so you see how these were together, which is basically times. We already used the law by making it a plus instead, because in that case we would be able to add the logarithm. So that's one thing done. After that, we're able to move the use the rule. I don't know what the names are, but like the power is able to be moved before the log, so it will transform into it will transform into this. They literally give it ln 12 take away t ln e equals ln 2. So yep, and then since the normal log, so basically the e, it is always a normal log, and that thingy-majiggy is equal to 1. So we can basically not, like, it can basically just, how can I explain, disappear, because 1 times anything is the same number. So it's basically like, you know, non-existing. So we can just like forget about it. So after that, ln 12 take away 2t equals ln 2. After that, we have to rearrange everything to make t the subject. So look, this is where it gets a bit hard. You might think, oh, we just have to move this here. That's one step to do. Well, no, guys. To make it more easy, I would recommend to always, if you have the ability to, make it positive. Because in that case, positive answers, they're just like not better, but like, how can I explain? You can actually like negative. How can I don't know how to explain exactly, but if you have the ability to make it positive, make it positive. So we're gonna go a bit of a harder way. So we could have used the law, like, you know, making this a division, but no, because we're gonna use it later basically, don't worry. So after that, we're gonna move the t to make it positive, and then we're gonna move this. So what we're gonna have at the end is 12 take away ln2 equals t equals, and after that, what is it? Oh, we're able to divide these. That's the law, ln2, and because these are like, we are able just basically, we can like you actually find out the numbers and then divide them, but we're able just to put ln6 because these divided give 6 and log is still the same. It's not going to be squared or something. So yeah, and that equals t. And so after that we find out the number for this, and the number for this is 1.79, and there's no units, so that's how you do this question. Okay, here's the next question. Over here we have to use, basically read it, yeah. We have to use, what's it called, the sine rule. It's given here, and this is in the formula, but basically it is, let me just do it, a over sine big A equals b over sine big B, and then there's a c sine C, but right now because there's no c we don't need it. So what A is this number, like the actual length, and the big ones are the degrees. So this is big A, this is small b, this is big B, and this is small a, as we can see. So we have to rearrange everything to make A the subject because we're looking for A. So that will be A equals B over sine B times sine A. So we just have to substitute the numbers in. A equals 12 divided by sine 40 times sine 30. And the answer to this is 9.33, and meters, over here it's meters, like for B, so it should be meters here. And also in general we would use meters, like if what you just convert it. Okay guys, here's the next question. So this is kind of a trick question for this one, because the actual units for direct stress is pascals. However, pascals is the same as newtons, like over meters squared, and there's no trick here. It's basically Young modulus. So here's the next question, basically read it, blah blah blah. So first of all, we have to convert the kilometers into meters per second, because for the formula, basically the formula is this, and we have to convert it into A because we're looking for acceleration. So for the acceleration, it's going to be, let me make this, yeah, acceleration equals v, the v, take away the u divided by time. So v is the initial, no, v is the end, like what's it going at. U is the initial velocity, so this is the right now velocity initial, and t is time. So this is the right now velocity, and we need it in meters a second because that's what we usually do. We always use meters and not kilo. So to convert this into like this thing, we're going to times it by 1,000, but also at the same time, so over here you see it's hours, right? We need to find it in seconds. In 1 hour there is 60 minutes. In 60 no oh yeah, in 60 meters minutes there's 3,600 seconds. So 60 minutes equals to 3,600 seconds. So to get this into meters, how you can think of it is, first of all, 100, right? Kilometers. Make it about the kilo. So we times it by 1,000, because times in a kilo is 10 to the power of 3, and 10 to the power of 3 is 1,000. So, yep, makes sense, right? So that will be times 1,000 equals basically, and then straight away, whatever you get here, you can divide it by 3,600. So we can kind of put it in the same one. I mean, if you do this, you get a different answer than this. So do it like this. Just make it all together, so you also don't confuse. You don't get confused at the same time. So we have the formula. So let's just substitute in the numbers. So the V is right here. 2. Okay, why is it like this? 27.77, and then take away 0. So yeah, basically nothing, divided by time, which is this 4.7, and all that equals to 5.91 meters a second squared. For accelerations squared, don't forget. And the reason it's squared is because over here we have a second, and over here we have a second. So 2 seconds times each other, like second squared. So that's how we get the squared. And then B. Calculate the force of which is the acceleration of the vehicle. So we have to find the force. To find the force, we use this formula. We have the mass and we have the acceleration over here. So we just times these two. So 1,569 times 5.9. Let's just put 9, and then that is equal to 9,257 newtons. Also in a calculator, you could get 9.3 times 10 to the power 3. So yeah, these two are the answers for this question. So here's the next question. Please read it. So over here this time they actually made it very simple. This is the formula, and what we need is we just basically have to substitute the values in. So the pressure is 1,000. I mean, no, let's not use these. Let's try not to use them. So pressure so the density of the water is 1,000 kilograms, and density is pressure, so 1,000. Why is it so big? Okay. After that, gravity we should know, 9.81. That's just like the basic for Earth. After that, the area, and area, as we know, is 5 times 9. So width times height equals 45. So 45. And after that, the x, and the x is basically it's basically the half of the triangle a bit. Sometimes if it's not a triangle, it's probably different from what I know, but it's mostly going to be triangles in questions. So it's half of 5, half of the height, so 22.5, and all this thing is equal to 1,103,625 newtons. Also might come out at 1 times this is what also come out as. So after that, second question. So calculate the turning moment around the base of the retaining wall. So in this case, we kind of have to, I don't understand it as good. However, basically, read this please and try to understand it yourself. But we have the formula, so let's just do it. So, the formula is, no, basically what we're looking for initially is HEP or whatever, and this is basically the formula. 2 over 3 divided, no, times by the height. So 2 over 3, and then over here we're just gonna times it by 5, because but if it's in the middle, like this, you move the number or whatever is over here on top and times it by this number or whatever like shows, and then the density above the base, like to calculate the density above the base, is what we need. No, first of all, this equals to 3.33 meters, by the way, and that's below the surface. So the distance above the base, so distance above 5 is the maximum, so 3.33, because that's what's below. We're looking for kind of the middle part, whatever's in the between. And now calculate the moment. The moment is given by force times the distance that we got. So let's just go 1 point. Yeah, I have it there. So 103. Basically this. I'll just put force here, and force times this, and then this all equals to 1.84 times 10 to the power of 6, and that's going to be Newton's meters. So that's how you get this question. Here's the next question. Please read it. Okay, explain one way in which the efficiency of the mechanical system might be increased. So what I would put for this is basically increase the input, because if you increase the input, the output will definitely increase, and that's the efficiency. No, efficiency is actually different. Basically, the efficiency is the percentage of how much the output actually comes out. So let's say the input is 100 newtons and the output is 50. That means the efficiency is 50%. So the way you can increase the efficiency is probably decrease in something, but I'm not really sure. I don't know, guys. Let's just go to the maths part straight away. Here's the question, and let's just crack on with it straight away. So first of all, this is the formula. So no, this is how you find A, and the actual formula is basically this whole thing. So basically, let's say A1, right? Pi times 32 squared divided by 4. Let me check on my calculator what it's going to be. That's going to be 804.24, and then for A2 we will do, instead of this we're gonna put 120. So let me just do that on the calculator. 120. 11309.73. So now that we have the areas, we're able just to do this super simple thing. this equation, right? So area 1, so 0.84, and then we times it by the velocity, which is 3. This is, whoa, huge answer, but that's the answer. And then we just divide it, we divide this. Basically, we kind of rearrange the formula. So look, this is the formula, right? And we just need V2 as the... So we need V2 on its own because we're looking for it, the velocity for the second one. So we just, this, move it here. It's a times, so this divided by the A2. And this is equal to this, so we just divide this by the A2, which is this. I just don't want to write it down. However, oops, let's go. Well, I don't know the answer. Yep. Divided by this. Let me just do it. 2412.7. 2 divided by 11309.73. Yeah, let's just do this. The answer should be similar. Oh, it's actually the same. I guess these points don't matter as much. I guess it's just, it gives the significant numbers. And these significant numbers are right. So, this is the V2, what we just got there. So 0.213. And that is in meters squared because that's the velocity. So, read it please. Calculate the vertical and horizontal reactions, forces present at point A. So we're looking only at point A. Over here, this is applying. Basically, this is a free body diagram, right? Which it makes it super more easier. However, it's not like it helps that much. But basically, this thing, we move it, we expand. No, we actually just make it same as this. The way we make it same as this is we times this by the whole of the thing. These all added, this the whole thing, it's 6 meters. So we do 8 times 6, that is 48. So we put it right in the middle. That's what you do when you find the thingamajiggy, you put it right in the middle, and it's in kilonewtons. So it's in 3 meters. After that, we have to resolve the 12 kilonewtons angle, so this. And what this basically means, it means this sine for the vertical and cos for the horizontal. And then straight away, let's just do the vertical component, because that's basically the only vertical component that we just need to find out because it's different from these ones. The reason it's different is because it's more applied. So I'm not sure, but basically it's just, yeah, this is how it is. So let's just find out what the basically we need to find what it is in this, like in an actual number. This in an actual number is 6. So this is worth 6 kilonewtons. Basically, yeah, that's how it is. And so after that, because it's an equilibrium, that means that's like fully not moving. We're able to find the horizontal equilibrium of the point. So the reason this one goes only upwards is I should have done a video about it, but I haven't. So when there's these circles, that means it's going over up. Like, it can be like this, but I'll make a video about it, I promise, soon. And this goes 2 ways. It goes horizontal and vertical. Yeah, horizontal and vertical, yeah. So let's find the horizontal. Yeah, horizontal first, because that's the only one. I mean, no, not, so look, there's one here, right? And one here. Equilibrium means that these two, they, when they combine, like, because they cancel each other, because they go the same direction, like, no, they're opposite each other, they cancel each other out, and cancelling each other out means equal and zero. So they equal zero, and basically, cause this equals 10.39 kilonewtons, and so they're the same. So A also equals this. After that, we have to take moments about B to find the vertical components of A, because again, you have to understand that the summary, this is the engineering way of summary, moments, this is moments, basically forces, but moments, yeah, of B, they should equal zero, because when they cancel minus this, it should equal zero, because like it's either way, this is also a moment, so it still applies to the moment area, so it equals zero. So from that we know that where was it? So we have the 6, oh no, where did, oh yeah, over here, 6 kilonewtons. The 6 kilonewtons is equal to this, so we know it's also a moment, so we will also add it. So I mean, we kind of have everything. Do we? Oh yeah, we actually do. So look, the 6 times A. So the A, as if altogether A, let's just put A. And the 6, because we're talking about this one. No, we're talking about this one, right? The reason we're not talking about this one is because right now we're looking for the, where does it say? We're looking for the vertical right now. Right now, me and you, we're looking for the vertical. We will do horizontal later. I mean, we kind of already found it, but I'll just explain on the go. So this, and then this, 3, 6. So look, B, it is 3 meters away from this one that we found with you, upwards, like we found it over here. Oops. And how you find the moments, you just times them. It's kind of simple. So yeah, that's how we got this. The way we got this is the same as this, and then this 2 times sine. So this is how you see, like, we're not looking for the horizontal, we're looking only the ones that are applying, like, vertically. All these equal to 0. So this equals to so this equals to 144. This equals to 56. This equals to 12. All of this equals to 212. And so 6 A's, like the what's it called, the vertical A's equal to 212, because again they cancel each other out. Because even though B equals to all of this and all of this equals to 0, so it's kind of the same thing, basically substitution, right? So we divide it by 6 to have only the A, which will be, dividing this by 6 equals to 35.33. And the way we found A, basically, kind of think of it like that. When you look at B, you're actually looking at A. When you look for A, no, when you're looking at A, you're actually looking at B. Like it's kind of like, again, because, oh, sorry, pardon me. When you're substituting or whatever, moving everything numbers this way, like, B equals, basically, yeah, I don't know how to explain it, but I understand it, so you kind of also should. So 3, where is this? 3. So the vertical for A we found it a while ago. This vertical's up. Is it vertical? Yeah. Oh no, I'm an idiot. Oh my god. So this is this. Ignore me, guys. This is this. Let me just. This is this. So sorry for the confusion. This is vertical. Oh my god, I'm about to die. So 35, 33, because we just found it. That's the vertical. Horizontal, we already found it again. They cancel each other out, so it's the same as this one. So 10.39. And here's the B part to this same question. So now we're looking at the actual. Oh, this time we're actually looking for the B. Like we're actually zooming onto the B, not A. So see, now we're looking in the rabbit ears at A, but we're actually looking at B. So basically, the whole B, like the summary, the vertical and the horizontal together combined, blah blah blah, equal to 6 B's, because that's the like the whole value of the thing. Times by the same forces, and they equal to 0, blah blah blah. So this equals difference from the last one, because last one, if you zoom in, for example, it was 14 times 4, and this time it is 14 times 2. So basically 48 times 3, let's just calculate 12. 48 times 3 equals, oh, it's the same thing, 144. This is 28, which is different. And then 4 times, wait, yeah, see, this one is also different. 4 times 12 sine 30. Oh, this equals 24. All these added equals to plus 144. All these added equals 96. 6. And then this equals to 6b. Divide this by the thingamajiggy. So b equals 327. And then for the vertical reaction, we can check the solution by doing all this maths, but I don't want to, so we're not doing it.